In the world of measurement, accuracy reigns supreme. Whether we are talking about the length of a bridge or the diameter of a tiny screw, obtaining precise measurements is paramount. This is where calibration comes into play. Calibration is the process of comparing a measuring instrument to a known standard to ensure its accuracy. It's like checking your watch against an atomic clock to make sure it's telling the right time. Calibration is crucial because even the most well-made instruments can drift from their intended accuracy over time. This can be due to factors like wear and tear, environmental changes, or even just regular use. By regularly calibrating our instruments, we ensure that they remain reliable and that our measurements are as accurate as possible. In this exploration of precision, we will delve into the world of three essential measuring instruments: the Vernier Caliper, the micrometer, and the Vernier height gauge. These tools are indispensable in various fields, from engineering and manufacturing to scientific research and quality control. We will uncover their intricacies, learn how to use them effectively, and most importantly, understand the critical role of calibration in maintaining their accuracy. The Vernier Caliper stands as a testament to human ingenuity in the quest for precise measurement. This seemingly simple tool, named after its inventor, the French mathematician Pierre Vernier, unlocks a world of possibilities for accurately determining the dimensions of objects. At its core, the Vernier Caliper is a versatile instrument used to measure both internal and external dimensions, as well as depths. Its ingenious design incorporates two scales, a main scale and a sliding vernier scale. The main scale, typically graduated in millimeters or inches, provides a baseline measurement. The Vernier scale, a smaller sliding scale, allows for remarkably precise readings by dividing the main scale's smallest increment into even smaller units. This clever combination of scales empowers users to obtain measurements with greater accuracy than possible with a simple ruler. Imagine needing to measure the thickness of a sheet of paper. A ruler might only tell you it's about a millimeter thick. A Vernier caliper, however, can reveal the thickness to be 0.1 millimeters or even more precisely depending on its resolution. This ability to measure with such fine detail makes the Vernier caliper an indispensable tool across a myriad of applications. To truly appreciate the elegance of the Vernier caliper, it's essential to understand its various parts and their functions. Let's break down the components of this ingenious measuring instrument. The main scale. This is the primary scale on the caliper, typically graduated in millimeters or inches. It provides the initial coarse measurement reading. The Vernier scale. This smaller sliding scale is the heart of the Vernier caliper's precision. It interacts with the main scale to provide measurements with finer increments. The fixed jaw. One of the two measuring surfaces of the caliper, the fixed jaw, remains stationary and serves as a reference point, the movable jaw. This jaw slides along the main scale and is used to adjust the caliper to the object being measured. The depth gauge, this thin, pointed extension attached to the movable jaw, allows for measuring depths of holes or recesses. The locking screw. This screw secures the movable jaw in place once the desired measurement is obtained, preventing accidental movement. Understanding the role of each component is crucial for using the Vernier caliper effectively and obtaining accurate readings. In the next section, we'll delve into the step-by-step process of using a Vernier caliper and explore the art of calibrating it for optimal performance. Before we can rely on a Vernier caliper to deliver precise measurements, we need to ensure it is properly calibrated. This is where gauge blocks come into play. Gauge blocks are precision-engineered blocks of hardened steel or ceramic with extremely flat and parallel surfaces. They come in various sizes, each with a precisely known dimension, often down to a millionth of an inch. Calibrating a Vernier caliper with gauge blocks involves the following steps. Select the appropriate gauge block. Choose a gauge block that corresponds to the measurement range you'll be using. Clean the caliper and gauge block. Ensure both surfaces are free of dust, debris, or oil that could affect the reading. Close the caliper jaws on the gauge block. Gently but firmly close the jaws of the caliper onto the gauge block, ensuring it's held squarely. Observe the Vernier scale reading. Note the reading on the Vernier scale where it aligns perfectly with a line on the main scale. Compared to the gauge block dimension, the Vernier scale reading should match the known dimension of the gauge block. Adjust if necessary. If a discrepancy is observed, the caliper may need to be adjusted. This usually involves a slight adjustment screw to align the 0 point of the Vernier scale with the 0 point of the main scale. Regular calibration with gauge blocks ensures that your vernier caliper remains a reliable tool for precise measurements. Now let's move on to another champion of precision, the micrometer.